Okay, so good morning, good afternoon, good evening, good night, whatever. Guys, hi. My name is Plainwala and I'm from Babaji's Flying Academy School. So today we are doing pressurization, favorite chapter. Why favorite? Because every time I want to explain any topic, simple automation related stuff, I go to pressurization. Okay, because you'll realize it while I'm going through the topic. Okay, so pressurization. What all do you need to know? What is pressurization? Okay, that's the basics. Pressurization is basically. Oh, I need to see the spelling. Sorry, and I hope the spelling is right after that also. And don't come after me for American English and British English and whatever Indian English I'm using, whatever. Okay. Anyways, pressurization is basically the amount of force per area. Okay, that is being affected onto the cabin. Okay, so if you notice, there is inside pressure and there is pressure that is exerted by the atmosphere onto the cabin. Okay, and this difference in pressure is called delta P. Okay, so basically what is delta P? Delta P is inside pressure minus outside pressure. Okay, now another thing we need to know, what is cabin altitude. Okay, so simple terms to remember it, the altitude which is being experienced in the cabin, what altitude is there in the cabin. Okay, just let me check. Kind of helps, I don't know, not sure. Just okay. Anyways, where was I? Yeah, cabin altitude. Now what is cabin vertical speed? So the rate of change of this altitude, whether the cabin altitude is increasing, decreasing, what is happening, that is called cabin vertical speed. It's the rate of change of. Okay, so it's basically by you could say like dt of. Okay, this is what it is basically. Okay, I know I shouldn't write this, so I will get confused, and I may be wrong also. So, anyways, so you need to know what's cabin VS also. It's the rate of change of your cabin altitude. Okay, these are your prerequisites for pressurization. Now let's go to the architecture. Okay, you all will see a black screen for some time. That's because I suck at editing and I can't show you the FCOM itself. Okay, because I don't know what's going to happen. Okay, so we are going to go to architecture now. So now let's see the architecture. Okay, so architecture is pretty simple, it's straightforward. We have, sorry, 1 second. Okay, so the okay guys, the architecture is very simple, it's straightforward. What we have is we have two CPCs, CPC1, CPC2. Okay, CPC1 is motor 1, it's powered by motor, like CPC1 is controlling motor 1. Okay, CPC2 is controlling motor 2. Okay, you will notice there's a manual motor which is controlled by the cabin pressure panel. Okay, so this motor is basically controlled by this man VS. Okay, now people get confused on, okay, what is this manual motor, what's this outflow valve and all. Okay, now the packs, like we did in the previous chapters, the packs does what? The pack is supplying the air to the cockpit. So what is happening is air is coming in, and obviously that's going to be pressurizing because you're adding air into the cockpit, and not only cockpit, but try to get the point, you're adding air into the aircraft. Now how do we control the pressurization is by controlling the amount of air that is coming out of the aircraft. So we control that air through this system called the outflow valve. Okay, the outflow valve is on the right hand side, rear of the fuselage. Okay, below the flotation line. Okay, this line out here is the flotation line. The flotation line is basically a line, an imaginary line, where the aircraft is expected to float in case of a ditching operation. So when you do ditching, the aircraft is supposed to float for some time, and the aircraft will float like below this line. The aircraft will be submerged in the water. So the outflow valve is below the flotation line. And your safety valves, you have two safety valves which are on the rear bulkhead. Okay, the bulkhead is like this one it's like one end of a cylinder kind of a thing. Have you seen a it's somewhat like a you've seen those soda cans, like your Coca-Cola cans and all. You see there is that bump here inside. Imagine that bump kind of a thing on the back of the fuselage. That's your rear bulkhead, and it's got two safety valves. Now these safety valves have been designed in such a way that they will automatically open. There is no connection or anything. If there is a difference in what you call pressure, what will happen is it is going to a difference in pressure is going to trigger the safety valve from like be operated. Okay. Yeah, that's the part of the safety valve. Okay. Now let's see what else. Okay, yeah. Now we're done with this. What else do we need to do is, CPC1, CPC2, safety valve, outflow valve. Okay. Now we have 5 systems which supply the CPCs. Okay. What are these 5 systems? It's an easy way to remember is LEEAF. Okay. So L is your LGCIU. Okay, 1 and 2. Then one of the E's is your emergency rammer. The other E is your engine interface unit. Okay, and then you have your ADIRS 1, 2 and 3, and finally F is your FMGC. Okay, so these 5 sensors send signals to the CPCs, and accordingly they control your cabin pressurization. Okay, why does the LGCIU give? It will give the aircraft, the CPC, the information key. Okay, is the aircraft on the ground? Is it not? Okay, is the landing gears compressed or not? The emergency rammer, is it open or not? Because if the emergency rammer is open, then pressurization is actually not happening, because it's like, what's the point of having the outflow valve then? That emergency rammer is already going to be open, air is already going to be entering through there. So if there's a differential pressure, then it might affect that area also. Then you have your EIU, which is your engine, how much N1 basically is being produced. What is N1? It is that big fan ka rotation, and after the big fan rotation you have your small little your other compressors through which your bleed is coming through. So from there you'll know how much pressure is coming in. Is it being able to supply the packs? Is the packs being able to supply the demand? Okay. Then you have what do you call ADIRS. So ADIRS also will give information about the differential pressure kind of. It will tell you outside what is the because it's ADIRS. Okay, so the air data also information is coming in. It's telling you how much the pressure is outside and everything. Okay, so the CPC knows how much differential pressure basically is being maintained. Okay, then what else do we have? So basically it's your static pressure that is coming in through there. Then F is FMGC. So FMGC will have your flight plan, what is going on in your flight plan, when where are you, what are you doing, are you coming in for an approach, should I be removing what do you call air from the aircraft or not, depending on which phase of flight you are in. And it automatically plans, because you have passengers in the back, you have to make sure that they are also comfortable, right? Okay, we are done with this. Okay, now we are done with this part. Now the outflow valve is controlled by two motors for automatic operations or semi-automatic operations also. We'll come to what is automatic and semi-automatic later. Just remember this for now. And you have one manual motor. Okay. So what is automatic and semi-automatic? Automatic operations, the CPCs are supposed to do everything automatically. They're supposed to maintain your pressure, is supposed to pressurize the aircraft, depressurize the aircraft, everything CPC is supposed to do. Okay. Semi-automatic is supposing one CPC is not being able to do its, like the FMGC does not have the, what you call your landing elevation. So if you see on top out here on this panel, there is a landing elevation auto. So right now you have selected it on auto. Okay, so what is fed in the FMGC, that is what it's going to be trying to follow. Okay, this is the landing elevation we are going to be at. Supposing that's not available in the FMGC, what you will do is you will turn this knob and you will check the ECAM of what landing elevation. It will come landing elevation man. Out there you will be able to see your landing elevation, what you're setting, and you can set whatever landing elevation you have. Okay, so it goes from -2000 to 14,000 feet. Okay, this range out here. Okay, so you're not supposed to see this knobs range, you're supposed to see it in the ECAM, what is the value coming. Okay, down there on the screen you need to see that. Okay, we are done with this. Now what is this manual backup? People get confused in this also. Manual backup is nothing. Each CPC has the manual backup for this manual motor attached to it. Okay, now the thing is that the manual backup has its own connection of power connection from the battery itself also. Okay, so the manual backup is protected. It's just that out here if you see, the manual backup which is connected to CPC1 is being able to display on the ECAM system. Okay, so that means CPC1 and CPC2 both have manual backups. It's just that the CPC1 ka that manual backup ka section will be able to display whatever the ECAM data is there of your manual ka setting you have kept. Okay, so the idea is ki if CPC1 fails, you won't get any ECAM system display or ECAM warning of this manual backup. Okay, what else? Let me check through my notes now. Safety valves I've told you. Okay, so safety valves values are 8.6 and -1.0. Remember this, it's important. They try to confuse you with this 8.6 part especially. I'll tell you later on where the confusion will come. Okay, so 8.6 and -1.0. Okay, then what else? The independent ECAM warning info. Okay, yeah, we're done with this page. Okay, so now automatic transfer between these two CPCs occurs 70 seconds after landing. Okay, if you remember, the air conditioning page had 70 knots. So if you want to remember something easily, you can just remember the number 70. For air conditioning it was 70 knots. 20 seconds later. For CPC it is 70 seconds after landing. Okay, see, even I had to confirm because you forget these things slowly. Okay, if the operating system fails, okay, supposing CPC1 fails, then it will automatically transfer to CPC2. Okay, otherwise CPC2 fails, it will automatically transfer to the other guy. So these are the two conditions and automatic transfer will happen. Okay, again I've told you automatic mode. Now let's explain how automatic mode works. Okay, so automatic transfer, how does it work? Automatic stuff. Okay, so you remember that 8.0, 8.6? Okay, I can't erase that part. Anyways, let's come to automatic mode. Automatic mode pre-pressurization is from year to year. Okay, so if you notice, the aircraft is pre-pressurized. That means air is added into the aircraft and it is given a pressurization of 0.1 psi, minus 400 feet per minute 0.1 psi is given. Okay, and then at liftoff it will start equalizing the pressure, and then it will maintain a slow pressure build up. Okay, so on ground delta P is 0, cabin Vs is 0, okay, and cabin altitude is your field elevation out here. Okay, then when before my takeoff is like before I lift off, there will be a pre-pressurization that will happen, which will be 400 feet per minute and 0.1 psi. Okay, after that, as the aircraft lifts off, normal pressurization will follow. Okay, it will normally pressurize, and it will pressurize automatically. The CPC will take it to 8.06. Remember, the safety valve, if it opens, you're going to get an ECAM warning and everything. So it must be below this safety valve setting. So the safety valve setting was 8.60. Okay, so that is like 60, and here it is only 6. So there's a 54 car difference basically. So 8.06 psi is what the CPC will try and maintain. 8.6 psi is what the safety valve will maintain. Okay, that's in case the CPCs are not being able to maintain this. At 8.6 the safety valve will go. You might read in the FCOM also somewhere that the safety valve indications will show that it's more than 8.60. That is because there will be like a sudden suction of air going through. So the sensor, because there is sudden suction of air, because that valve is opened suddenly, what happens, it overreads the thing, because the sensor is out right next to the valve. So when the valve opens out now, that time that air will gush to that point, and that's why you'll find that the pressure was a little higher, but actually your pressure was at 8.6 only, it's opened out. Okay, anyways, that is the safety valve and all. Pressurization is done till 8.06. then depressurization, that's when you're coming down, it comes to 500 feet per minute, will maintain maximum, and it will go to 0.1 psi. Now you'll ask me ki plane wala, you to said ki depressurization, pre-pressurization, why is there this 0.1 psi? Okay, 0.1 psi na, you need to consider passengers behind. Okay, so it's for passenger comfort, they keep this 0.1 psi ka pressure differential. Okay, so in case I'm doing a go around, then it will maintain that 0.1 throughout. In case when I'm taking off also, it will give me 0.1, so that sudden rotate pe, that sudden pressurization ka jhatka they don't get. Okay, it's passenger comfort. If they didn't want to keep it, they couldn't. They could have left it, and the aircraft would operate fine. It's just passenger comfort, and passengers are paying money. Semi-automatic mode. The case of dual FMGC failure, there is no field landing elevation information given. Okay, so in that case, because there is no dual, like if your landing elevation is not given, you just select it from top. In short, that is what semi-automatic mode does. Okay, you just select it from top, then what will happen, it will say, okay, whatever is selected on top, that's what we are going to follow. And in manual mode, finally, manual mode is where you will press the manual push button, and then with the VS you'll be able to select the outflow valve, closed or open. Okay, now remember the outflow valve is like this. Okay, so when I put it up, man VS up, this is basically opening up, so air is being able to come out. Okay, and in case I put it down, then the valve closes. Okay, so try to imagine the thing, otherwise how you memorize it ki, okay, if I'm going up, it means it's climbing, so that means it should be depressurizing the aircraft. You want to do it that way, you can do it that way, otherwise you can visualize it and do it both ways. It's up to you how you have learned it, it's okay. Okay, now due to slow operation of this outflow valve, okay, it takes time for the sensor to figure out ki how much is your actual rate. So it is told that you must use this man VS, use it for like 1 second or 3-4 seconds, and then see on the ECAM actually where your VS has settled at, because it will keep on building up. So you will keep on pulling it, not realizing that you have opened the outflow valve too much then. then you'll always be playing with the man vs. So it's just like a warning. It's told that don't keep on keeping it open or closed. Just open it, keep it for like 1-2 seconds open, leave it, then see what you get. If it is enough, you leave it. If it's not enough, again you keep it for 1-2 seconds, again see what it is left, like that. So slow incremental bursts may you'll do this. Okay, now what else do we have? Man okay, now in manual mode your target vs for climb will be around 500 feet per minute, and in descent you will have 300 feet per minute. This is manual mode. Okay, in what do you call, in automatic mode you have a maximum cabin descent rate. Maximum of how much they can keep is 750 feet per minute. Okay, and this residual pressure, so that means 750 feet per minute. I'm talking about which part? I'm talking about this part. This segment is 750 feet per minute maximum. Okay, whereas this part is released at 500 feet per minute at the maximum. Okay, what else do we need to know? What else? Okay, the outflow valve is on the right hand side, rear fuselage below flotation line. Safety valves, there are 2 safety valves, but the ECAM will have only one symbol for it. Okay, that one symbol signifies both the safety valves. So any one of the safety valves open on the ECAM, you will see that it is opened. That's it. Okay, outflow valve, again the outflow valve opens both ways. So supposing this was the valve will open like this. Okay, so one comes inward and one goes outward. Okay, so the idea is कि if both the valves open in different directions, depressurization of the aircraft is easier. Okay, because it won't matter कि whether the high pressure is inside or outside, both ways one of the halves should open easily. Okay, then what else do we have? We have something called a RPCU. Okay, what is the RPCU? RPCU is a residual pressure control unit. Okay, residual pressure control unit. So now what happens is sometimes pilots forget that we have kept it in manual mode. We have landed the aircraft and the outflow valve was in manual mode. Maybe a CPC failure, maybe a CPC failure, maybe like you have manually kept it in that mode, maybe the outflow valve is not opening on its own, some problem is there with the signal going to it. So what it does is it says okay, the outflow valve is in manual mode, it's not opened by the pilot, I'll open it. Okay, so it depressurizes the aircraft in case of 4 conditions that must be satisfied. So what are these 4 conditions? Okay, it will be कि the outflow valve is not fully open. Okay, it may be partially open and stuck partially open, but it is not fully open and both your CPCs have failed or you're in manual mode. Okay, and the aircraft is on ground and all engines have shut down, otherwise all ADIRS is giving a reading of below 100 knots. Okay, that is RPCU. Now finally we have the ditching push button. Now the ditching push button is a little tricky topic. Little tricky meaning when you press the ditching push button, you are telling the aircraft, I am planning to put the aircraft down in water. Okay, I'm going to float it on water now. So there is a line which I had shown you, which is called the flotation line. Below this, the aircraft is actually below the water color level. So the issue is that if you leave these valves open, water can flood into the aircraft. So the ditching push button automatically closes these valves. So if you're in a manual mode, okay, otherwise you have pushed this ditching push button accidentally, you can pressurize the aircraft because the outflow valve will have been shut, but air would be continuously adding inside because you are in the air and you have accidentally pressed this ditching push button. Air is just keeping on getting pumped inside the aircraft. So this is like one important thing to realize कि don't accidentally press this button. Okay, the outflow valve will get closed, the emergency ram air inlets get closed, your sorry, there's only one emergency ram air inlet, your Avionics ventilation inlet and outlet valve is inlet and inlet outlet valve. Basically, the avionics inlet and the one which is outlet, which is also called extract. In this case, they have called it extract, but it's outlet valve are closed. Okay, and your pack flow control valves are closed. Your forward cargo outlet isolation valves are also closed. Okay, so. Yeah, this is majority of the stuff you need to know. Another thing you need to know is about the emergency ram air inlet. The emergency ram air inlet won't open if there is a cabin differential pressure greater than 1 psi. Okay, and that the reason for that is because now the aircraft is pressurized. So if the aircraft is pressurized and I open this valve, basically the air will go through this valve outside, because the higher pressure is within the aircraft. So it finds this valve is opened out. It says, okay, atmosphere is out there, let's go out there. Okay, so it damages this duct because there is air, you're ramming air into it also, and air is coming out from that side. Okay, so to prevent any sudden depressurization or anything of the aircraft, also it won't open if there is delta P greater than 1 psi. Okay. Now if I push the emergency ram air push button, okay, and my delta is less than 1 psi, then automatically your outflow valve will open 50% in automatic mode. Okay, the outflow valve, because now the emergency ram air, supposing we are below 1 psi. Okay, supposing I'm below 1 psi, what is happening is, if I'm below 1 psi, emergency ram air is coming in. Okay, outflow valve is out here somewhere, air is going out from this outflow valve. Okay, the idea is air must come in, and if air is coming in, air must also go out. Okay, so that's why when you press the emergency ram air push button, what is happening is the ram air is also opening out and the outflow valve is opening 50% on automatic mode. If you have in manual mode, then you'll have to manually sit and select the outflow valve to open. Okay, if I press the ditching push button, that valve is not going to open. Okay, now the another issue with the ditching push button is, if I'm on ground and I've pushed the ditching push button and the low pressure ground connection is kept in for the AC unit, then it'll keep on pressurizing the aircraft. Then the aircraft gets pressurized immediately. Okay, so you have to be careful of that. Okay, we're done with pressurization. Maybe I might just do this the next chapter today. Please like, share, subscribe, comment if you have any questions. If I've taught anything wrong, correct me, and yeah, subscribe. What else?